All right, we're so glad that you've joined the November 2025 TAM customer webinar. The goal of this webinar is to provide our customers with the opportunity to interact with great speakers to help you get the full benefit from your VMware by Broadcom solutions. Before we get into today's content, just a couple of basic announcements. As you see on the screen now, that during our next TAM customer webinar, which is going to be on December 4th, we'll learn how integrated networking services in VCF 9 can help you simplify your network deployment, consumption, and operations to speed up application deployment in the private cloud. So watch for that invite to that session from your TAM in the next week or two. And your thoughtful questions are part of what makes this webinar valuable. So please use the Q&A feature of Zoom to ask your questions. If we're unable to answer those questions during this webinar, then be sure to reach out to your TAM and ask them to follow up on your behalf. At the end of today's session, you'll be prompted to fill out a simple 2-question survey related to the value that you receive from this session and any topic suggestions for future sessions. We do review and appreciate every single one of those responses that you submit. And lastly, this webinar is being recorded, and your TAM can make that recording link available to you. After a few months, the recording will be publicly available on the VMware TAM Services YouTube channel. So that brings us to today's speaker and topic. So I've seen Will Arroyo present this topic of modern infrastructure management with VCF 9 internally. It was a great topic, so I'm going to get out of the way so that he can share that with you today. Will, over to you.
Thanks. Hey everyone, my name is Will Arroyo. I'm a solution architect within VCF. I focus on all things around modern apps. So really what that means is within our portfolio, kind of everything to do with Kubernetes, VCF cloud services. So I'll talk about what that means, and really anything around like deploying apps, managing infrastructure in a modern way, our supervisor and all the services around that, VKS, etc. So what I'm going to walk through today is a couple pieces. It's mostly going to be demo and whiteboard. I'll pause here and there for questions, so please put questions into the Q&A, and I'll try and answer as many of those live as possible. And I'm going to show kind of how we use automation to build out Kubernetes clusters. Also talk through how we can build virtual machines with Kubernetes, and deploy some software into those clusters. And then also a bit how it works behind the scenes. So I'll just go ahead and get started. Let me share. All right. Okay. So just to kind of set a baseline here, when we talk about cloud services and modern infrastructure management, I think it's good to set just a base here of like what it is we're actually talking about. So if you look at something, around, let's say, something like Azure or something like that, right? Typically out in the public cloud, you've got some general low level, you've got your compute that sits down here, you've got your let's call it like IAM, you've got your storage, all this stuff. We know that, in the public cloud, many of these pieces are like, you're not going and adding machines, like physical machines for compute, but generally, some policy and stuff like that is being set. Let's just call it like, quoting and policy and things like that. All of this stuff is set kind of at these low levels within your cloud. And typically this stuff is handled by your cloud admin team. And that could be the same team that manages vSphere. It could be really anybody. We'll just kind of talk about them as the cloud admin team right now. That cloud admin team usually sets all this stuff up, and that then provides kind of our next layer, which is going to be the services within that, right? And those services that get made available by this are typically your things like, compute generally is a service, but it's typically in the form of, a virtual machine. Or in the case of Azure, you might have AKS. And then also we're probably going to have things like, load balancing and network and things like that, right? So the ability to add load balancers, another one down here I should probably just mention is like the core networking, VPCs, etc. And then, there's a lot of services that fall into this category. Pretty much anything anyone consumes out in the public cloud. And that could be, let's say another popular one that I typically see out there is secrets. So all these services are then generally consumed by, this might be consumed by the cloud admin team, but also typically something like a platform, a DevOps, maybe a dev team or something like that. But usually some infrastructure focused teams that are building solutions on top of the core platform. So then we've got our next layer, which is going to be our devs. Or, it might be many dev teams. It also might be, again, cloud admin teams might be consuming this stuff as well. Really kind of, it builds all the way up where anybody can use these after the core services are there. So from there, somebody might be saying, hey, I want to now consume that virtual machine and deploy some apps on top of it. Or I might consume a Kubernetes cluster that was built by the platform team, and I want to deploy some apps on it, right, from a dev team perspective. Or, I need to add some secrets into a secret store of some kind that is handled through this service. So this is kind of like a typical set of layers, I think, when we look at services being consumed in the cloud and how they're consumed. We'll talk about in a minute, but really, this is kind of that model. So what I want to do is now say, okay, well, how are we doing this on top of VCF now? So if I just change some of these words around and change that to VCF, and let's change this to VKS. And let's change this to, it's still VMs, but I'll just make it more specific, the VM service. Now, we've kind of changed what had like, a couple words related to public cloud into VCF. And this is the direction we're going with VCF 9, is building a set of services on top of your core infrastructure that are consumable through APIs in a common way that allow platform teams, dev teams, cloud admins, all these teams to kind of successfully build and deploy apps on top of this. And it's not just focused on apps. Like I'll use apps here and there, but what I'm really talking about is the way that we consume the infrastructure. So rather than consuming these infrastructure services through let's go, find all these different APIs or use all these different ways of consuming it. How are we making these a centralized consumption, a way of centralizing the consumption and having these teams be able to do this in a way that mimics the way that somebody is managing maybe their public cloud. So this is really kind of the big picture of what we're going to be talking about. And now we'll get into a bit of how this works and showing some of it working as well. So I'll pause right there for questions before I move on. And just throw those into Q&A as we go. All right, great. So moving on a bit from this, what I'm going to do is actually start with the demo. And the reason I'm going to do that is because in my lab, it takes a couple minutes to build the virtual machines and things like that. So then we'll talk through kind of what's happening as that happens. So this demo is going to walk through creating a VKS cluster. Sorry, first it's going to create a supervisor service, supervisor namespace based on some supervisor services. We're then going to create, and I'll talk about what a supervisor is, don't worry. Then we're going to create a VKS cluster. We're going to also deploy Argo CD. We're going to bootstrap those clusters with some core software that's needed for application teams to consume that. So we're going to be going from kind of a cloud admin who sets up the core infrastructure into a platform team that is going to um, run some Terraform to do this, and then a dev team who's going to consume it, because we'll cover all these stacks. So after we then deploy our Argo CD, wire it up with our Kubernetes cluster, we're also going to then deploy an application into that cluster. So all those components are going to essentially be handled with a very simple Terraform apply command. So getting into that, let me share a bit more here. All right. Okay, so let's jump in and kind of look at some of the behind the scenes. So I've got my VCF 9 environment out here. I'm going to log into my VCF automation um, cloud portal here. So VCF automation in this case is really going to be kind of like the main consumption area for people to come in, whether those are platform teams or dev teams. They're going to come in, and this is how they're going to create virtual machines, create Kubernetes clusters, create load balancers, all of these things. I like to generally think of this as like if I logged into the Azure portal, that's what VCF automation is, right? So this is that centralized place to go in and do things. Now I'm going to click around a bit in the UI, but everything here is generally accessible via the API. And also what I'll talk about is how the API is now a bit different and can be used in a more common way. So just starting out as kind of that cloud admin, I have manage and govern as one of the things I can do. So what this will let me do is create some projects, assign users to those projects. I can also have different orgs here. So I'm logged into one org. If I log into what's called the provider portal of this, I can then create more orgs. So I'll give a quick peek into what that looks like as well, because I think it's useful to kind of see what a full cloud admin will be able to see back here. And I'm not going to dive super deep into this because I want to hit on kind of the consumption piece of it. But if I log into the provider, so this is something only a cloud admin or an org admin, I should say, would have access to. So you can see that I have different organizations out here. Within those organizations, I can assign regions and region quotas to them. So again, when we're looking at kind of that diagram here, this is this layer of access that we're talking about, this kind of bottom piece, right? I can assign users, I can wire up my OIDC into this. I can then assign supervisors into my regions and zones within those. I can make virtual machine classes available. Basically, I can restrict down these orgs to only have the storage, the networks, the VM classes, and the areas that I want them to go use, right? Within networking, you'll see a number of other pieces here, right? I've got ingress and egress traffic set up. I've got my IP spaces that can be used. All of this stuff is kind of configured within this provider portal. And there's a bunch of other bits inside of this. Again, I'm not going to go super deep into this, but just know that I create an org as an admin. That kind of wires in how does this org know where it's going to provision things, and that's because I've now told the org, here are the regions you have access to and the quotas around those regions. And a region is really going to, for the purpose of what I'm talking about now, associate itself to a supervisor within a vCenter. So I'll draw this out a bit as well after the demo kicks off, so that you can really see how this is functioning behind the scenes. But for now, that's kind of what we're talking about when we say an org is kind of setting up that core underlying infrastructure piece. Now, if I jump back into our consumption side of things, so within the actual tenant, within the org, we'll see that I have a project that I've created. Within that project, I have some namespaces. I've got a couple out here. We're going to create a new one. And then you can see the regions that I have access to and the utilization on them. So right now I've only got access to a US West region. And again, as a cloud admin in here, I'm kind of seeing this manage and govern section. So I could also set up policy within this. The policy piece is really interesting. I think I'll touch on this a bit after we get into some of the creation of this. Uh, Now jumping into kind of that platform engineering layer of how am I going to deploy some things, right? So I've got this UI, I can go around and click in. I'll show that in a second. But what I really want to do first is kick off my Terraform and show you kind of what is going to happen here. So I'm going to jump back into my Terraform over here. And I've got some Terraform code that I'll just touch on briefly. And what this does is, like I was talking about, it's going to create a supervisor namespace. It's going to also then create an Argo CD instance. It's going to bootstrap it all together. It's going to create a Kubernetes cluster using VKS. It's going to wire that cluster back to Argo CD, and then I'm going to deploy an Argo CD application that goes and deploys an actual app. So this kind of puts together two personas really, which would be a platform engineer coming in and actually utilizing those services, and then a developer actually deploying an app. So typically these might be spaced out so that developers are managing their own Git repos with this type of stuff. But just to make this kind of simplified for demo purpose, I've stuck those two together. And behind the scenes, you can see these are Terraform modules. Behind the scenes of this module is honestly not a lot of code. So if we look at what it takes to actually deploy Argo CD, this is really the meat of it right here, an Argo CD instance. And some of you might notice this is using a Kubernetes manifest to do this, and we're using the Kubernetes provider to do this. And that's because, as I'll start to talk about here, is most of our APIs are now being surfaced through a common API, which is a Kubernetes API. And I'll really dive into that here in a few. But that's why it looks like this. And then behind the scenes, what this is actually doing, if we go look at kind of vCenter, I've got some services deployed, and I'm going to show kind of the low level here behind the scenes of the supervisor. So within the supervisor, we have these things called supervisor services. Supervisor services are how many of those services that I was talking about here, this layer, are now being created and exposed as APIs. What that means is a lot of services are running on this supervisor cluster, which is a out-of-the-box Kubernetes cluster. And that is going to then handle a lot of the creation of these infrastructure components that we need. So what we've got deployed in here is an Argo CD service. We can see that we have VKS deployed on here as well, the Kubernetes service, and the VM service. So those are the main ones I'm going to be talking about. The Argo CD service is what's allowing us to create multiple Argo CD instances based on namespace or wherever it may be. And what that actually allows us to do is, as you have tenants that come in, you can very simply spin up an Argo CD instance for those tenants. That they only have access to, and so on. So, and with a tiny bit of code here, right? I mean, this is basically it. That will install Argo CD for me, wire it up with a load balancer, do all the work, right? And you'll see that here in a second. So let's kick this off. And I'm just going to run a Terraform apply. And we can see it's talking to the supervisor, going to create a namespace for us, and we'll go ahead and hit yes. And then what we'll see is, oops, didn't mean to do that. Inside of our namespaces, we'll see a new namespace show up, which looks like it's this 4H1. And you can see some limits and things have auto been associated with it. So CPU memory, no limit on storage in this case. We're going to see some pods start to spin up, which once it starts deploying Argo CD, it's going to do that. But you can see a bunch of stuff is starting to happen over here, right? And this namespace, if you're coming from like an 8 background where we had supervisor and namespaces already, nothing really changes there. What's happening though is now we're kind of layering on the VCF automation piece to aggregate all of that up and wrap some more around it. So we can see that we've got 4 namespaces now. The new one has showed up here. If I go into this, we can then change into that namespace and I'll start to see things get created. So you can see there's a new VM that's starting to be created. That's actually part of a Kubernetes cluster. So if I click on Kubernetes, we should see, yep, we've got a new Kubernetes cluster being built. And we can see Terraform is doing all this work behind the scenes, right? So that's actively creating my Kubernetes cluster, my Argo CD instances, all of that type of stuff. When I look back here into my inventory on the supervisor, and I look inside of this, so I'm actually looking at my namespace in the inventory, I can see my cluster is there, and also all of my Argo CD pods are deployed. So Argo CD runs as a set of pods on the supervisor, meaning that these aren't deployed into another Kubernetes cluster somewhere. They're actually using the supervisor to run, which does a number of things. It's going to allow us for we don't have to spin up a Kubernetes cluster to deploy Argo CD, which is really great because it solves that kind of bootstrapping problem. And it also utilizes the ESX hosts for capacity here. And it's putting it directly within our namespace so that our quotas and everything apply to that as well. So this really simplifies the deployment of that Argo CD so that you're not having to worry about where do I get my bootstrap cluster from to then install Argo CD on it to then manage other things with it. I'm going to pause right here for some questions before I jump into some other pieces.
Looks like they're following along well, Will.
Cool.
The participant count is staying up, so they're not leaving. Right? And,
That's always good.
Yep.
Please post something in the Q&A that says, hey, I'm about to leave. Can you talk about this before you leave?
There you go.
All right, so that's going to keep deploying. So while it deploys, let's talk a little bit about how this is working. Oh, good question. Do you need to use Terraform? Absolutely not. And that's a perfect question to lead into what I'm about to show, is how you can do this using many different tools and how the API is really consistent. So let's get into that. All right, so I'm just going to make this bigger so that we don't have to zoom in as far. All right. So let's talk about what's going on here. So we've got VCF automation. I'm going to refer to that as VCFA right now. VCFA, like I said, is kind of that central point for how we're interacting with our APIs, our consumption, all of that stuff. So within VCFA, we've got a number of different components here, and I'm going to keep this fairly simple from like the architecture of the tenancy and stuff like that. There could be a whole session on how that's set up, but generally within this, you're going to have an org, right? And that org is then going to have access to some regions. So let's say we have a region inside of this, and that region is going to aggregate up a lot of different details like networking and things like that within it, right? So behind the scenes here, then we're also going to have, let's kind of build out our region, right? So let's make this a region. All right, so this region here is going to point at this, right? And this region is actually going to be within it our supervisor. And just to also kind of keep this somewhat simplified, right? This is running, inside like this is vCenter here. Like one of your vCenters has a supervisor in it. And I'll just make this a whole box just so it's more clear. All right, so vCenter. You can have multiple regions inside of here, right? So you could have many regions inside of a vCenter and so on. But the main point of this being that what we're doing is we're connecting up VCFA to a region. Inside of that region, there's a supervisor, and that supervisor cluster is also utilizing, ESX down here as a as its worker node. So again, I'm not going to get super deep into the actual inner workings of how the supervisor does all this because it could take the whole session. But if you're familiar with this from the past, it's still functioning the same way. The supervisor itself is a Kubernetes cluster that gets spun up when you deploy a workload domain or when you, let's say, you do like just deploy a vCenter in an ESX cluster and turn on the supervisor. You can do it that way as well. So the supervisor itself comes up. It's a Kubernetes cluster. Its worker nodes are ESX, and that piece is important because that's kind of how we utilize pods within the supervisor without having to deploy another Kubernetes cluster to run those. So going through this a bit more, right? So we've got our VCFA, which is kind of our centralized place. We've got our org, we've got our region within that, and we're talking to our supervisor. So what we're going to now do is talk through how does this kind of work that the stuff we just did. So let's draw this out here. So the first thing is what this enables is to have multiple of these, right? Multiple regions and so on. And this supervisor has a Kubernetes API that sits on top of it. And the Kubernetes API is an extensible API that allows for adding, new APIs to it, building kind of your own infrastructure services within to it, and all kinds of things. It's utilized by many, many vendors, by companies to kind of extend that Kubernetes API. And the other thing about it is that it's declarative. So when we start to deploy services, as an example, we want to consume some services within VCF A, right? So let's say we have our VKS service, and then we have our Argo CD service, and then we have our VM service, which are the main ones I'm going to talk about. Right? These services are all now talking to services that exist on the supervisor. So what we're doing is surfacing those services up through the supervisor up to a centralized place inside of VCF automation. So if I do my VM service, and one thing you'll notice here is I could actually have different services in different regions. One region, it might be useful to have something like a database service like DSM. Another region, it might not be useful to do that. So then we've got the, let's say Argo CD here. And then let's just say this region also wanted to provide DSM, the database service in this case. So then we could have essentially the same exact thing over here in another region that's talking up to, it could even be using the same org, right? So if I wanted to, let's draw out another region over here, right? And this region would have no DSM, right? But the point of this being that now you've got kind of multiple regions, multiple supervisors that are now all centralized up through one area, one API basically. And that one API being our VCFA. So there's a question in chat. Every region will have at least one supervisor to talk with VCFA. So the what I'm talking through here is, I should clarify, VCF automation, um, all apps. So you'll hear all apps and you'll hear VM apps. So if you're coming from using VCF automation, the VM apps side of VCFA is the traditional way of consuming VCF automation, which is, you know, everything you're used to. The all app side is new with VCF 9. And that's what we're talking through. And that heavily utilizes the supervisor for provisioning and for the services. So to answer your question, um, when you spin up a supervisor, like that will become basically you'll tie your VCFA to a region which has a supervisor in it. So yes, to utilize this functionality, you will need a supervisor within a region. Awesome. Okay, so these services again are going to live kind of within VCFA. They're going to be surfaced up from the underlying supervisors into those regions. And then what sits up here as well is another Kubernetes API. There's also a REST API, I should point out, within this. So if we just kind of show all the things that are available here, right? So we've got a Kubernetes API that sits on VCFA. This is kind of like a meta Kubernetes API that then proxies down into these different regions so that you can, again, surface these APIs centrally, right? That way I don't have to go direct to the supervisor. I can actually come in through VCF automation. I can talk to a specific org in a region through one centralized API, and that is a Kubernetes API. So if I want to get a Kubernetes cluster, I can say, hey, I want a Kubernetes cluster. If I want an Argo CD instance or a virtual machine, all of that's flowing through here. Now that also has, you know, a UI that's going to talk to that, and we're also going to have, you know, some other traditional REST APIs out here, right? So there's a number of different ways to kind of consume VCFA, but this path is really what I'm going to be talking about. And what that means, finally getting to the question about needing to use Terraform, is that up here we have like, how do you consume these things? And typically, you know, customers have a number of different ways of how they want to consume infrastructure. You know, I want to build a VM. I want to use Terraform. I want to build a Kubernetes cluster. Maybe I want to use Ansible. Maybe I want to use Ansible for everything, or maybe I want to use Pulumi or Bash scripts, whatever it might be, right? So that's where we can start to place all of these different tools out here, like Terraform, like you know, Ansible. What if I want to consume this stuff with something like Argo CD even? Like, what if I just want to do GitOps? What about, you know, Pulumi? I think you're starting to get the point here. I'm not going to write every infrastructure tool that exists on the planet out here. But if there's one specifically, just throw it out in chat and I'll say yes or no. So all of these tools now can consume this API because every one of these services are surfaced up through this centralized API. So if your favorite tool has a way to talk to a Kubernetes API, it can now be used against the VCFA API to build out VMs, to build out Kubernetes clusters, to create load balancers, to create VPCs, to do all of that stuff. That can all now be done through this common API. So when I'm talking about common APIs and a common way of managing this stuff, it's really behind the scenes, the Kubernetes API is making this possible. And we're not talking about the Kubernetes API in terms of how do I deploy applications? It's the Kubernetes API in terms of an infrastructure API for cloud admins, for platform engineers, developers, whoever it is that wants to consume infrastructure in an automated, consistent way. Now there are APIs that are all surfaced up through the Kubernetes API to create those things. And typically also, right, you're using these same tools to consume your public cloud infra as well, right? So one of the points I want to make here is that by kind of going this direction with VCF, we're really saying rather than us creating a bunch of, let's call it unique ways to consume the VCF infrastructure and to orchestrate all that, you likely already have tools that are your favorite for orchestrating infrastructure. So let's just make it easy for you to do that, right? And that's what this enables really at the highest level, is an easy way to consume all these different services that are being made available. And these services could be more services out here. There are more services already, but because this is a extensible API, and we're utilizing this to build out all of these new services, for example, like the private AI service, right? That's another one in here that will be exposed the same way. DSM, as I mentioned down there. What if I wanted to have just a custom service? Like if I am a customer and I have my own internal service that I want to expose through VCFA for people to consume. And that might be like, I want to be able to create tickets through here or something like that. I don't know. I'm just making something up. You could write a custom ticket service that could also be exposed through this same API. So it's not just extensible from a VMware standpoint, it's extensible for customers to also build their own services that can be consumed this way, which I think is a huge piece here that will provide a lot of value. So I'm just going to do a quick recap of the big picture here before I pause and then we'll get back to some of the demo pieces. So big picture, right? You can utilize these tools, any tool you want, really, bash scripts, etc., to build your infrastructure, Kubernetes clusters, virtual machines, networks, VPCs, all of this stuff through VCFA using a common API that's backed by the Kubernetes API. All through this centralized place that has tenancy built around it, that has your OIDC integrated, that has quotas, that has policy, that has all this stuff that can then target multiple regions, aka supervisors in this case, across multiple vCenters and ESX clusters. And all of those can now be deployed through VCFA down to those through a centralized API with centralized RBAC policy, et cetera. Right. So that's kind of the big picture of why I guess this is important. And I'll get a little deeper into this even around the API portion of it. But I just want to pause right there for any questions before I jump back to what happened with our Terraform, what did it deploy, etc. There's a question from John. These are just RESTful APIs between regions, no etcd traffic between regions, assuming there's some distance between regions. Good question. So the supervisors themselves are the Kubernetes clusters, right? So if we take a quick look at kind of that architecture, what that looks like is a supervisor cluster is sitting in, and there's two ways you can deploy a supervisor cluster. You can have a supervisor cluster basically deployed into an ESX cluster, right? And what that ends up being is a supervisor cluster is made up of, in a high availability situation, 3 control plane nodes, right? So you've got your control planes, And this is across, let's say this is one ESX cluster deployment, right? So this supervisor cluster then utilizes that ESX cluster as worker nodes, right? So as many hosts as you have in here become worker nodes of this cluster. etcd is running here across these control plane nodes, which are all in this case, one region. So, and in this case, one zone also, right? So you'd have 3 etcd nodes spread across these, right? So that's the general like quick architecture of a supervisor cluster and how it works. Now you can also spread this out across 3. So we'll do it this way. This supervisor cluster, let me get rid of this, can be spread across multiple ESX clusters, right? And you can do a zonal deployment, right? This also is going to be, you wouldn't want to do this across areas with super high latency or something like that as well, right? But just to illustrate the point, you can create zones for these, and now you have a 3 availability zone supervisor cluster that's spread across those ESX clusters. Regions themselves are going to generally be treated as separate supervisor clusters, right? So this would still be one region, even though it's spread across multiple ESX clusters, but you're not going to have like multiple regions sharing control plane nodes across them. So hopefully that answers the question, John. Awesome.
Yep, he confirmed that it did.
Great. Okay, so that gets us a little bit into also the architecture of the supervisor, which is good. So let's jump back and see what kind of has happened with our deployment. So we should see we've got 2 virtual machines. This is a 1x1 Kubernetes cluster, 1 control plane, 1 worker. And if I jump into my automation consumption, we've got our, let's go look at our overview here. We've got a Kubernetes cluster. We've got some virtual machines. So if I go to my Kubernetes cluster, we'll see that it is ready. And what I'm going to point out here is, even though I'm using the UI here, I can look at the YAML of what was deployed, right? So we'll actually see what the spec looks like for this entire Kubernetes cluster that we deployed, right? So again, highlighting that a Kubernetes cluster in this case is also being deployed utilizing the Kubernetes API. If we look at a virtual machine, let's close these things out. And I go, this is my control plane virtual machine as an example, and I look at the details, we'll also see the virtual machine is a Kubernetes resource in the supervisor. So just again highlighting that, oh, these are just Kubernetes objects in the supervisor. These are Kubernetes APIs, not talking about deploying Kubernetes apps. Again, we're talking about we're utilizing the value of the Kubernetes API, which I'll touch on here in a second, to manage our infrastructure. You'll also probably see within here that we've got, if I go to network, we can look at our VM load balancers, and you'll see that a load balancer was also created for this Kubernetes cluster because I need a way to ingress into my Kubernetes cluster for the API. So when I create that cluster, this happens automatically, but we can then see what does the YAML look like for that. So this virtual machine service is a load balancer that is targeting port 6443 on port 6443, and here's our IP. So this is, I'm showing kind of the details of how this Kubernetes cluster was created using these objects. You don't have to individually create these, but you can for deploying virtual machines, which I'll show in a second as well. So this is again just highlighting that load balancers, virtual machines, Kubernetes clusters are all going through this API that is backed by those services that we were talking about. So it looks like everything came up. What I want to do now is go look at, all right, where is my, let me pull this up. Our Terraform should be completed. Oh no, it failed on something. That's okay. Let's just rerun. I think I know why that failed, but I'll just rerun it real quick and it should say that it. There we go. Updated admin secret. And hopefully this, there we go. All right, great. So here's my Argo IP. So I'm going to take that. I'm going to go out here and log in. You can set up correct certs and everything on this. I just didn't in this case. So if that's a concern, don't worry, you can do that. I'm going to log in and we'll see that Argo CD is up. So this was deployed while we were talking. It also wired up my clusters into it automatically. So I'm talking to the supervisor cluster here and the namespace. So our namespace is connected, as well as our new VKS cluster that we just deployed. So what that means is that not only can I now use Argo CD to deploy apps into my clusters, I can also use Argo CD to deploy other things into the supervisor. So if I wanted to control, for example, cluster creation, virtual machine creation, load balancer creation, all of that stuff through Argo CD, I've now enabled the ability to do that. So you'll see a couple different apps have gotten deployed in Argo. One set up some observability, one set up our standard repo that is going to wire up the ability to deploy packages. And then finally, we've got our app that was deployed targeting our VKS cluster. Everything looks healthy, which is great. And I'm going to jump back into our Kubernetes cluster and see if our metrics have started flowing. So another bit of this is we want all of this to come up in a way that provides like out of the box metrics, observability, all of that stuff, right? So let's see, make sure there's something going on here. Uh-oh. Lab troubles, hopefully not. Okay, we'll give that a minute to sort itself out. Okay, so while that maybe just becomes healthy, let's talk through what kind of just happened as well. So actually, you know what? I can jump into ops and show you some things real quick. Well, another piece of kind of the whole puzzle here is the I just mentioned the observability component of this. So with that, we've automatically wired up these VKS clusters into operations. So I'm going to go take a look at my objects, and we're not using any management packs here in 9. Like this is a native integration. So we can see our supervisor. We can go to our VKS cluster, and let's go find that cluster. So I'm just going to click on topology. I need to clean up some old ones out here, it looks like. There we go. So we can see the topology for this GitOps cluster has come up. And I've got 2 clusters out there actually, so this is fine. And as those metrics start flowing, we should see that they will start picking up pod metrics as well. But you can see that you can already monitor just the clusters themselves from here, as well as the supervisor itself from within here, right? So here's my supervisor, and we should be able to see, yep, there's the whole topology of that, which is quite big because now you can see all the components within each supervisor namespace and so on. So all this is just happening as I deploy this infrastructure, which is really nice. So let's jump over here, and looks like there might be a question. Let me go to Q&A. Oh, no, we just need to mark that one. There we go. Any questions before I dive a little deeper into kind of what happened when we deployed that, and then how that's actually possible that we deployed this stuff? All right. Okay. Just a quick refresh. There we go. All right. There we go. A small blip. So I'm going to click on monitor in here just to kind of tie that last bit together. So what you'll see is the new cluster that we just deployed. Also within VCF automation, we're tying in the metrics from ops. So what that looks like, right, is we deploy this cluster, we wire it up with Argo CD, Telegraph is then shipping metrics from the VKS cluster back to ops, and ops is natively integrated with automation. And kind of correlates all these components together. So now we can see the actual components. There's not a lot of metrics yet because it just came up, but we can actually see the components within the cluster. So these are all pods within our cluster that we can go look at and just check on the health of them, right? And also the virtual machines are here as well. If we look at another namespace that I've had up for a while, you'll see a lot more metrics come out of this. So let's click here and look at one that's been up a while. And now you'll see, hopefully, there we go. You can see a bunch of metrics on all of these components now over time. So this gives, I think, some good visibility, not only for the ops team that might be using ops, but if a developer is utilizing a Kubernetes cluster and they log into VCF automation, now they're able to see, oh, look, my pod is like using a ton of memory or something, some quick glance type stuff that's really, really useful for those devs to see what's going on. Got something in Q&A, pull that up real quick. Oh, great question. Sean Harris, that's a familiar name. Hey, Sean. So yes, that is again leading me right into where I was headed with this. So TMC, for anybody that has used it before, Tanzu Mission Control. That was part of the Tanzu portfolio. A few months back, a number of components from the Tanzu portfolio were moved into VCF. TMC is one of those. So within VCF 9, TMC has been baked into the platform, so it's not a separate component. So if I go into Manage and Govern, this is kind of another piece where, like, probably a platform engineer or cloud admin is going to be handling this, but you've got this Kubernetes management section now. So this is actually TMC baked into VCFA. So what's great about this is you're not deploying a separate component, a separate UI, and all of this stuff into here. This is just natively out of the box. And what you'll see is the clusters are automatically attached to it. So there's no separate attaching or wiring up or anything like that. And then you'll get policy and all the things that TMC provided out of the box as well. So you can see that there's my project. Here's my clusters within that. And if I wanted to go in and assign some security policy, I could create a security policy here, just like I did in TMC. You'll also have quota custom for doing OPA-based policy, mutation policy, all of that stuff that was in TMC is here, as well as configuring your target locations for backups, and so on. So there's a few pieces here that you won't see yet. This is 9.0.1 specifically that I'm showing you. In future releases, there will be more pieces of kind of Kubernetes management moving in there. So just stay on the lookout for more release notes and things like that. But this is all baked in now, so you're not going to have to go to another place to see any of this stuff. Insights, all these components that were kind of there for TMC, all here. So another piece that I'll touch on with this is when you go into here, if you were using backups, right, enable data protection, still there as well. So again, kind of right out of the box, you're able to go in and create your clusters through the APIs, have them wired into Kubernetes management, formerly known as TMC, and be able to do your backups, do your add-ons, all of that type of stuff that was available for you. So it's all there. Great question, and thanks for leading me into that, Sean. All right, so let's take a quick look at kind of what happened here with this demo. Actually, before I do that, let me just show really quickly. We actually got an app deployed onto this new cluster, right? So within Argo CD, if you haven't seen it before, it tracks like all the resources that were deployed. So you can see within here that, you know, this is we have like a music store app that has a number of components associated with it. One of those being the music store service, and I can grab my IP from that. I didn't wire in DNS into this, but also completely doable. I think this listens on port 5000, and there we go. The application is up and running. So that again happened with just that Terraform apply. So let's talk through kind of how that worked really quick. So we'll do this in more of a flow than an architecture style. So what this looks like really is we have VCFA, and we've got our K8s API within here, and then we have Terraform. So Terraform has kind of all of our stuff we want to create. That talks to the Kubernetes API on VCFA, and Terraform is going to orchestrate all these pieces out of this. But what's going to happen first is it's going to create us a namespace. So this is going to be a supervisor namespace within the underlying region that we were talking about. So we get a supervisor namespace. And that supervisor namespace is going to have limits and quotas all around it. So if we go take a quick look at that, and we look at our namespace, we can see this is the new one we created. Let's go take a peek at that. What we'll see is that we have our limits over here, right? We have 100 gig storage, 10 gig memory, 10 gigahertz CPU. Those are all configured through what we call namespace classes. So namespace classes allow that cloud admin to provision kind of a default set of classes, like we had VM classes, but in this case, making it easy to create a namespace with predefined sets of resources and things like that. You can also override those when you create a namespace as well. But that's kind of how that piece is working. So we create that namespace. The next thing that happens is Terraform's going to deploy into that namespace an Argo CD instance. So again, this is coming from our Argo CD service, fully supported, everything. It allows us to create an Argo CD instance using some minimal YAML, right? And that's what we showed here in the Terraform, right? So this piece. That actually is where Terraform creates that, stands up that Argo CD instance. Following that, we're also going to create inside this supervisor namespace via Terraform a VKS cluster. Right, that VKS cluster is then wired back in to Argo CD, as well as the supervisor namespace being wired into Argo CD. So those pieces are what I showed here, just kind of highlighting all of these bits, right? When you see these clusters showing up in here, we've got the supervisor namespace as well as the VKS cluster. This is important because this is what allows you to target those with Argo CD. I'm going to remove these lines just because they get a bit confusing. So we've got our VKS cluster, we've got it all wired in, and then it's also going to deploy into here our music store app, as well as what I'm going to call the baseline apps. which are, for example, like our standard repo and, you know, Telegraph, let's say in this case, for monitoring. So all of that stuff is kind of what happened through this API when we ran that Terraform apply. So I'll pause again really quickly there. Any questions on what's happening there? And just to highlight the point here, right? If you don't want this to be Terraform and you want this to be Ansible, all of this is 100% doable with that, or whatever flavor tool you like. So we've got Q&A. Jacob. Thanks, Jacob. All right. So another piece I want to touch on really quick is we talked a lot about the Argo CD VKS cluster flow of things. Now, what if you just want to create some virtual machines, but you want to do it in a Kubernetes way? You know, there's a lot of I guess hype and talk around tools out there, things like KubeVirt, et cetera, for creating virtual machines using a Kubernetes API, and that provides a lot of value because now you have a single API to provision Kubernetes clusters and virtual machines, unifying that way you automate things, which is a lot of what we're talking about here, unifying the API and the way you create infrastructure. So what we have is the virtual machine service, right? And one big piece of this is the virtual machines that are being created with the virtual machine service are just vSphere VMs. They're not like a nested VM in Kubernetes. There's usually a lot of discussion around, oh, well, if I create a virtual machine using Kubernetes, is that like inside of a Kubernetes cluster or a VM inside of a VM or something like that? It's absolutely not. These are virtual machines created directly on ESX, just as if I went into the vSphere UI, deployed OVF, right? So if I wanted to create a virtual machine out here, I can click Create VM, deploy from OVF. I could choose, you know, an OVF from a content library. I can choose the virtual machine class that I want. I can choose my storage class that I want. I can do persistent volumes that I want to attach to this. Maybe I want to add a load balancer to access it. So if I want like an SSH LB, I can call this SSH. I can say I want port 2222 to target port 22. I can add that, save. I can do a cloud init customization, so I can drop my cloud init directly into here. And then I can add network interfaces to this, right? Set up DNS, all of the bits that I would need to make this actually work as a virtual machine. And I can click deploy on that VM. Now, why is this any different than going through a vSphere UI or something like that? Well, as you'll see kind of on the right-hand side here, there's actual YAML being defined for this, right? I'm just going to change this up a bit to show. But for example, if I had some valid cloud init, which I don't right now, test cloud init, you'll see that these objects are getting created, and these different Kubernetes objects. So now I've got a secret with some user data in it, which would hold my cloud init config. I've got a virtual machine service, which is my load balancer, and I've got my virtual machine that's referencing my cloud init. So all of this YAML deploys my virtual machine, adds a load balancer, and cloud init bootstraps it. And that's all done through the Kubernetes API, right? So these virtual machines that you create you can take this code, you can drop it into Argo CD, into a Git repo that Argo CD uses. You can deploy this with Terraform, Ansible, etc. Main point being this YAML is no different than deploying a Kubernetes cluster with YAML or deploying really any of the infrastructure we're talking about with YAML. So now you've got this nice kind of standardized API to deploy virtual machines, load balancers around them, and configure those virtual machines all through the same interface that you're creating, you know, Kubernetes clusters now. Now, behind the scenes, again, this VM that gets created is not going to be a virtual machine that is any different than a virtual machine you create with like the vSphere client or something like that. So there's no need to be concerned with, oh no, like what's the performance going to be, things like that, right? This is a standard VM on an ESX host. Now I'm going to click deploy. I don't know if
Hey,
this will
Will,
work. Yeah, go ahead.
related to that, there's a question just I think directly related to what you just said. Are the VMs created with the VM service still not manageable in the same way as traditional VMs? I think you just
Yes, good question. Yeah, so they are generally locked down from a like from the vSphere uh, from the vSphere UI, and that's just mainly because it's like, hey, this is being managed by the supervisor, so changes you would make directly on a virtual machine would get overwritten because it's being managed by the supervisor with a Kubernetes, you know, with a Kubernetes reconcile loop, which I can talk about here in a second as well. So if you do look at this in vSphere, we should see here's our new VM that's powering up, right? So this is the virtual machine that I just showed. So it says consumer managed. Um, you know, some of this stuff is going to be grayed out, but you still can mess with this if you're a full admin, but it's generally not recommended because you'll create kind of a sync problem here where the supervisor is constantly reconciling that virtual machine to make it meet its desired state. And if you're changing it in vSphere, those settings won't be applied. Does that answer your question, Sean? Hopefully. Awesome. Thanks. Um, so uh, does this Kubernetes API send the K8s native objects to the API server and the VM objects over to Borg, assuming that's still a thing? A little wary of KubeVirt and networking is pure NSX. Good questions. So the way that this VM service works is it's not using Borg. So like Borg, just to clarify on some of these things, like Borg was a um, Google kind of infrastructure automation tool. Bosch came out of that, which might also be being referenced here, which was used by Cloud Foundry, PKS turned into TKGI, all of that type of stuff. So those were kind of like automation tools that were being used. I'll just say Bosch was being used by Cloud Foundry, right, to create virtual machines. In this case, the virtual machine service is a service that is running within the supervisor. So it is right here. It's a set of controllers running on the supervisor that handle talking to the vSphere API. So what that looks like is basically you've got your supervisor API, which is the Kubernetes API, and then behind the scenes of that, and this kind of gets into kind of how Kubernetes works a bit. Kubernetes has these things called CRDs. CRDs are a way to extend the Kubernetes API, custom resource definitions. So, for example, with the virtual machine, we can say, this is how we do this. We extend this with a virtual machine CRD. That virtual machine CRD surfaces itself into the API as what you see in that YAML as a virtual machine, right? A type that can be used, right? So that when somebody says, hey, I want to create a virtual machine, let's say they use kubectl, and they say, go create my virtual machine, which is basically this YAML here, right? Virtual machine. It goes into the Kubernetes API, aka gets stored in etcd. And then behind the scenes of that, there are things called controllers. Kubernetes controllers are just code that runs in a pod somewhere that handles making API calls somewhere, right? So this controller is constantly, this VM service controller is constantly watching that virtual machine CRD, right? And this is just standard how Kubernetes works. When I talk about a reconcile loop and also things like declarative, right? We're declaring what we want a virtual machine to look like in our YAML. So rather than saying like a bunch of scripting power on, add storage, do all this stuff. We just declare the state of the virtual machine. We apply that into the Kubernetes API. It gets stored. The controller, the VM service in this case, is constantly watching that virtual machine object for changes, for updates, for new ones to show up. And when that happens, the virtual machine service then calls out to the vSphere API behind the scenes to go provision that VM or update that VM or do whatever you told it in the desired state that you have, this declarative manifest. So that's how it's functioning. So behind the scenes, right, this is absolutely a VM running directly on ESX. And really, we're just talking about a different way to consume it via another API. We're not talking about the VM running in a different way or performing or anything like that, right? We're just talking about, rather than using something like PowerShell over here with PowerCLI to write a bunch of scripts that talk to the vSphere API, we're just using a continuously reconciling loop that takes a desired state and calls the vSphere API, right? So that's when if somebody's not necessarily comfortable with KubeVirt or something like that, I want to highlight this is not functioning like KubeVirt. The main thing we're doing is servicing an infrastructure API for virtual machines through Kubernetes, but we're essentially just making it so you don't have to write a bunch of scripts against the vSphere API. You can just define a virtual machine in YAML. Hopefully that clears it up a bit.
Yep, he confirmed the same that it did.
Awesome. And then there was the second question on there about, is networking pure NSX? From a VCF 9 perspective, what I'm showing you is all NSX. So like VPCs are an NSX construct. And the load balancers and things we're creating right now are NSX. Now, you could also integrate Avi into that to do Avi load balancing. And you can also, like, for example, with the virtual machine service, VKS, all of those things can use VDS networking. However, there are some restrictions overall in terms of the functionality of VCF automation specifically, if you're not using NSX because of the VPCs that make a lot of the networking components possible, like being able to spin up VPCs on demand, attaching namespaces to VPCs, all of that stuff is not available without NSX. So hopefully that makes sense. Awesome. Cool. I wanted to go through this anyway, so thanks for asking that question. All right, cool. So that highlights kind of how the Kubernetes API works a bit behind the scenes, how our virtual machine service works, how we're creating all of this through Terraform or any other API. And then I think the last bit I'll touch on here is just before I wrap it up, is that the so this kind of flow I showed here around how a virtual machine service works, right? Like this same thing is being used when we talk about VKS or when we talk about building new services, right? When I'm saying, hey, we have an extensible API that we can build more cloud services on, for example, like this, right? All these cloud services being consumed through that common API. The strategy of using Kubernetes CRDs to surface those APIs through the supervisor is really how we're making that work. So I just want to hit on that point that a lot of the power of this comes from utilizing this supervisor and the services within the supervisor. And then also that I touched on this custom service piece, but like the Kubernetes API is fully extensible, and we're also making this possible for third parties, et cetera, to extend services into this, right? So if there's something that you're really wanting to build a service for in your environment and you want to consume that through VCFA, we can absolutely discuss how you can do that, and it's totally possible. So I think this makes this a really flexible framework for building and consuming APIs, not only for us delivering it to you as a product, but also for customers to start using that, like yourselves, as you see fit. So I think that kind of wraps up all the pieces here. I'll pause and take questions, or if there's something specifically you want me to show or that I didn't hit on, let me know and I'll show it in the next few minutes that we have. So in that case, VCFA needs NSX mandatory. So for certain functionality of VCFA, it requires NSX. It's not fully mandatory though.
And just a little pitch for next month's webinar. Like I mentioned at the beginning, I think it ties well to what you were describing, Will, with the VPCs, and I think we'll get into that a lot more next month too. So be sure to come back for that one if it's interesting to you. All right.
Hopefully
Any
this
last
was helpful.
questions? Oh, yeah. So how's the integration to VCF ops now?
Good question. So is there a specific integration, or are you talking the VCFA integration, or just generally VCF ops integration? I guess let me. I'll just kind of talk about it a bit. VCFA to VCF. Okay, cool. So the integration happens. So basically, the core integration with ops is right now for, and again, I'm talking all apps, not not the uh, not the traditional stuff, right? So for the objects you're creating, like VKS clusters and virtual machines, it's automatically pulling these in. So when you deploy VCFA, it's automatically wired to ops and starts collecting these metrics and passing them through, right? So really, like ops is automatically collecting metrics, I guess is the best way to say it, for like all of your supervisor objects down. So clusters, the pods and everything within those clusters, the virtual machines, everything like that, virtual machines that are created through VM service and so on, all of that's automatically happening. Now, for Kubernetes clusters specifically, the collection to ops happens through a combination of Prometheus collectors, so like the node exporter and a couple others, that then Telegraph ships to ops through a cloud proxy. So rather than having like in historically with Kubernetes integrations and ops, you had the management pack and you had to wire up some stuff. That's no longer the case. There's actually a cloud proxy endpoint that we can directly ship metrics to through Telegraph, which means also like generally there's a Telegraph integration to ship metrics to ops, which is really nice. So that's how the metrics are actually flowing up to ops. And when you deploy a cluster, it's automatically wired in with the like details on how to connect back to ops. So you're not having to configure all those details and everything like that. Like the supervisor and VKS all handle wiring that stuff for you. So that all flows back up into ops, and then VCFA is just querying ops for this information. So when we go into VCFA and you look at this metric, these metrics, like this is because VCFA knows where this VM is in ops and is automatically making those API calls to surface this information. Same with the Kubernetes clusters, right? When we go to monitor. So hopefully that answers the question. All right, there are a couple other questions out here. Can namespace allocation tie into inflow blocks? So you're talking about from a IP standpoint or a DNS standpoint, or I'm guessing IPs in this case. So the namespace allocation, when you're creating a namespace through VCFA, is coming from NSX VPCs. So there's not an integration there. Now there is, and honestly, that one might be one to follow up with. Like I would reach out to your account team maybe on the details of the Infoblox integration that you want to dig into. But the main Infoblox integration I'm aware of is through Avi for handling DNS and things like that. So there might be another, but I would say maybe follow up with your account team specifically on info blocks. Um, so you do not need to add cAdvisor containers to create. That's correct. Yes, that whole cAdvisor thing, all of that stuff is gone in 9 for VCF Ops. It's much simpler. Honestly, that was a huge pain point for me in the past, was wiring the cAdvisor stuff, creating an account in VCF Ops, dealing with the cleanup of that, the automation of that. You no longer have to do any of that stuff. Um, Literally, like when you deploy a VKS cluster, telegraph points at VCF Ops and it starts shipping metrics. Is there a Rosetta Stone type of chart to designate order of operations across SEC Ops API Explorer? That's a good question. I am not sure if there's one, but I think the question you're asking here is like, is there something that shows like how all these pieces talk to each other, which APIs are available, etc. That that's something that would be very helpful. I haven't seen one personally, but that's very interesting. I think it'd be well worth having something like that. So maybe I'll follow up with the product teams and see if something like this exists. But uh, if you don't see anything soon, reach out to your account team and then tell them to reach out to me, and we can dig in.
All right, looks like you've gotten through the questions that are out there. And so this was super. Again, I was excited about it with my accounts, talking to them about it, and just it was as useful, even more useful, seeing it a second time. So thanks, Tonwell, for just the time you've put into thinking through this and just making it so easy to understand through the visuals. It's great. There was a question about whether you're able to make that lucid chart. Like, are you able to export that? Or are you able to share that as a public or something like that after the fact that you can?
Yes, I can
So
make this public readable for everyone.
yeah, perfect. And so if you get me that link, I can I'll post it with the recording and the TAMs can get it out there and everything like that. Okay, so super.
All right, I just did that, and I'll send it to you, and you can share it out.
Yeah, perfect. Thanks so much. And just a reminder again, next month, December 4th, we've got the webinar on VCF 9 networking services. It just fits well with the groundwork that Will's just laid in place, just focusing in on some of those pieces that he highlighted that really just provide additional value here. And so, thanks for joining in today. You can get this recording from your TAM, and that link will also be shared. And we'll look forward to seeing you next time. Thanks so much.
Thanks.